thing right off the bat is that the glaciers that are melting here, and all of them are in what we call a negative mass balance, which means they're losing mass, they're retreating, that water's going into the ocean, which is causing rise in sea level. So we see that in Maine, and sea level has been going up and accelerating for the last, I'd say, decade or so, and we're really, really concerned about some major events happening in the near future. So when I come back to Maine, I have basically two kind of projects that I do there. One is monitoring beaches in the coastal zone, and students actually got me interested in doing that a number of years ago. And the coastal changes are it's kind of intricate because you see really rapid changes that occur seasonally and with big storms, but very slow and steady and gradual changes that happen as a result of sea level rise. And we're starting to see it with the migration of the beaches, especially our own Morse Mountain, Seawall Beach. I can actually bring you to a site down there, show you where the beachfront was in when did I first start? Well, my first student worked down there in 1992, and we can show you where he mapped the dunes in 1992. And he actually has a data set that goes back to 1980s. So we're actually comparing the rate of shoreline retreat as a result of sea level rise from basically the 80s to present. And every year I have one or two students who are coastal and interns, that actually a great position that's funded by the community of Small Point, which is down in Phippsburg. And the two students this year, you may know Claire Marconic and Sam Rickerich, and they're my two interns this summer working on a number of projects, but primarily mapping the dunes. In all my work, what we want to do is to be able to make a baseline of observations against which future changes are going to take place. So, and actually the baseline is moving, so if we have all these observations, we can actually start to see how change is taking place over a longer period of time. And, I think that's a fair explanation of what I'm doing in Maine in the coastal work. If you're familiar with the hockey stick diagram that was published first by Michael Mann from Penn State University. And the hockey stick diagram shows Northern Hemisphere temperatures. And their first reconstruction had it about 600, then they had about 1,000-year record. And if you think about a hockey stick, it has a long handle, and then it has a blade. Well, the long handle was dropping down, like if you tilt the blade down, that was the hockey stick the temperatures going down, into what we call the Little Ice Age. And then the blade of the stick starts at 1850 and goes to present. And if you look at the temperatures, the northern hemisphere average temperatures, even global temperatures, jump up at a rate we haven't seen before. Okay, the Arctic, you should look up, Google the term Arctic amplification and look for a map, and you can see that the Arctic has warmed faster than any other place in the northern hemisphere. And it's starting in the post 1960s, and so I think the rate of change really has increased. And if we look at our glacier, for instance, I think I included a little graph that showed the observations we've made in terms of the rate of retreat of the glacier. And you can see it retreating from 1936 to 1960. And about 1990s, the rate of retreat, the angle of climb of that graph goes up. And so we're really seeing that, when we go back to the glacier every year, the stakes that we put in to measure the amount of snow that accumulates in the winter and ice that melts in the summer, they're basically melting out. So we had, I think, 8 stakes going up the center line of this glacier, and then, at last count, we were down to 6 because the ice front has retreated past it. past the first two sites. So pretty, I think the rate of change, has really accelerated. The other thing that we all point to now and we all recognize is that the rate of change of sea ice loss, and that's something that colleagues of mine have been working on. And sea ice loss really is perplexing. There are computer models that predict how fast, given the temperatures, that the sea ice is going to disappear and thin and decrease in extent. But our observations are not fitting the models, in fact, that the observations are much faster than the models. We're losing ice faster than our predictions. So, and that has all kinds of ramifications. And this year, my colleagues who are depending on sea ice for their research, there's no sea ice on the whole West Coast here. In fact, I made in that PowerPoint, I showed that Svalbard is relatively warm for its latitude, and because it's at the northern end of the Gulf Stream. Well, Gulf Stream waters are in all the western fjords, and the warm waters are up against the glacier fronts and accelerating the glacier retreat. Warm water mollusks like bivalves, clams, and other like snow crabs and other things are following this drift in. So, I think the rate of change is amazingly fast right now. One thing I would love to do is walk people through my field area and show them the impacts. And I think, honestly, I think Americans are coming around as wholesale. And if you think about Maine is a very conservative place, right? And if you look at the changes that have happened in Maine in recent years, since I moved there in 1987, the changes are astounding. I mean, the length of the winter season, for instance, which manifests itself in a lot of different ways, in terms of the maple syrup industry, the ski industry, conservative people who drive snowmobiles for a hobby, ice fishing as a hobby. You see all these winter oriented activities, and people who work in these industries actually know this. And people who are farmers, one of my things that I'd like to do with my first year seminar next year is to get a panel made up of someone who works in the ski industry, a local farmer who has records, and I've actually talked to this guy out in Sabatis, who has records of freeze and thaw and maple syrup production over many, many years. Local fishermen, the lobstermen, who are seeing changes. The people who are doing fishing on the coast and seeing the fish migrating north, basically. So yeah, that's what I've been thinking the last couple of years. I think that the more people who start seeing impacts, they're going to have to start to come around, and the increase in violent storms, intense weather. How do we slow climate change? We might be able to adapt, and that's very costly. If you look at, the Netherlands, they've been trying to keep sea level rise at bay for a long time. And, it's a very intricate setup they have there with, dikes and levees and all kinds of things. The infrastructure is just amazing. So I think doing that on a large scale in the United States is really tough. I've seen plans for what, an ideal situation, would look like in New York City, how they would put up walls to protect storm surge, but preventing climate change it's like, I don't know if we already have a runaway train here. If what we know is true, the greenhouse gases that are in the atmosphere have a residence time, and that residence time, for carbon dioxide is relatively long. I remember a figure something like 170 years. So if we stop right now, just a draconian cut in emissions, it's going to take a while for that CO2 to be taken out. Now, I think the best thing that could happen would be for someone to invent or come up with a technology that takes CO2 out of the atmosphere and sequesters it or neutralizes it. And I don't see that happening very quickly. So, I think Maine adaptation, I think, is really a big first step. If sea level rise is going to ramp up, with the loss of the ice sheets, and Greenland and Antarctica are really the big dogs. I mean, if they go, geologic history has told us that sea level rise can really take off at much faster rates than we're seeing now.